Yes. Today we are going to discuss in the electrochemistry electrolytic cell. In the electrolytic cell, fused NaCl. Yesterday already we discussed. Today we are going to discuss aqueous NaCl electrolysis process. Okay. In the electrolysis, water is there, right? Aqueous NaOH means what? Aqueous NaCl means what? NaCl dissolved in the water. So here dissolved in the water. So what will happen here? Na plus Cl minus as well. H plus OH minus. OH minus. Total 4 ions are present in the given solution. In this solution, 4 ions are there. 2 cations, 2 anions. Right. Here, this battery, the big one is positive, the smaller one is negative. The positive attached, this positive attached electrode, it is generally platinum electrode. These platinum electrodes, these are not reactive. Okay. This positive terminal attached electrode is known as anode. Is known as anode. Is it visible? Yes. The negative terminal attached electrode is known as cathode. Cathode. Right. What about charge? Charge will be anode. Anode is attached with the positive, that's why positive charge. Cathode is negative charge. Cathode is negative charge. This much clear? Here, Na plus is there, H plus is there. Two cations are there. Positive particles in general, the positive particle move towards negative charged electrode. Which one is the negative electrode? This one is the negative electrode. See here, all electrons are there. Electrons are there. Electrons, electrons, electrons. So total negative charge is there. So these two cations are going. Now if Na plus is taking electron forming Na, if H plus is taking electron forming H, that means here you have to take two electrons, 2H plus H2. Because H single, it does not exist. Hydrogen is a diatomic molecule, always present as H2. Okay, right. Now, in these two possibilities, which possibility reaction takes place in this case? Either Na plus will take electron faster or H plus will take electron and forming hydrogen. Which reaction will take place? Yes, H plus will take the electron. H plus will take the electron because sodium is highly reactive. In the case of metal, reactivity means losing tendency of electron. So obviously, sodium is stable as Na plus. That's why sodium plus is not ready to take the electron. So it won't take the electron. H plus will take the electron and forming H2. Which type of reaction it is? Reduction reaction. We know that already at cathode, which type of reaction takes place? Reduction reaction. Next, here anode may what's happened? Anode is positive charge. Anode is positive charge. So obviously negative particles will reach here. Those are OH minus. OH minus is losing electron forming H2O and half O2. H2O and half O2. If I take 2 OH minus, then losing 2 electrons. You can take 4 OH minus. You can take 4 OH minus and water oxygen. Right? Next, another one is there Cl minus and forming 2Cl minus I am taking. Chlorine gas is a diatomic molecule losing 2 electron. Both are oxidation reactions. Both are oxidation reaction. Now which reaction will takes place? Either Cl minus lose the electron forming Cl2 or OH minus lose the electron and forming oxygen gas. Which reaction takes place here? In that case, what you will do, see, chlorine and here minus means what? Minus, oxygen is the minus. Oxygen is the minus. O minus and Cl minus, which is more stable? O minus and Cl minus. Which is ready to lose the electron? O minus or Cl minus? In the periodic table, सबसे highest more electronegative atom is F minus. F fluorine. Fluorine always taking electron, keeping it with it. Okay. Second highest electronegative atom is oxygen minus. It is also always taking electron from all elements except fluorine. Okay. Chlorine is third or fourth position. Nitrogen and chlorine almost equal. So now the question is oxygen and Cl, which is ready to lose the electron? Oxygen minus or Cl minus, which is ready to lose the electron? For that you have to know which is holding the electron strongly. ये बताओ, which is holding the electron strongly? Oxygen minus or sorry, which is holding electron strongly? Prathamesh given O minus. O minus is strongly holding means obviously Cl is ready to lose. That is all enough. This is holding strongly means it is losing electrons. So this reaction will take place. This reaction cannot. Got it? So finally, this is oxidation. Both are oxidation reaction only, but above reaction cannot take place. The below one is more feasibility is there. So at anode, oxidation reaction takes place. Chlorine gas is liberating, not oxygen gas. Chlorine gas is liberating. Here, hydrogen gas is liberating. Is it clear? Important question. Many times you can see the PYQs. They will ask you in aqueous NaCl, which gas is liberate at anode and cathode? Such type of question may ask. Okay, so here this is the logic. Two cations are there. In the two cations, which will take the electron, just you can observe it and you can write it according to reactivity and electrode potential values, reduction potential values. Okay, here OH minus Cl minus, simple logic. Okay, due to electron negativity also one of the factor we can decide which is losing electrons. So chlorine is losing electron forming chlorine gas. Okay, understood clearly? You can take screenshot if you want. Then yeah, take it better screenshot. Next, aqueous NaCl is over. Now you have to know the order of this depositing order, which will take the electrons first. So if you know the reactivity order, potassium, see before that the reactivity order, metals reactivity order is down the group increasing, left to right decreasing. What is this? Metal reactivity order I am telling you. Metal reactivity order. Reactivity order. If you know this statement, you can remember easily, right? Abhi sodium, potassium, rubidium, cesium like this is there. So potassium and sodium, which is more reactive? Potassium is more reactive, sodium is less reactive. In case of magnesium and calcium, calcium is more reactive, then magnesium is less reactive, then aluminum is less reactive. Why? It's the first period, second period, third period. When period is, sorry, first group, second group, third group. Okay, left to right by moving the metal reactivity decreasing. Okay, similarly here if hydrogen is there, hydrogen before iron before zinc. Okay, then after hydrogen, generally copper, silver, gold. But two more you can write copper, silver, gold. In between silver and copper here, mercury will come. Silver and iron, each में platinum will come. Okay, this is the order. What is this? Reactivity order. Reactivity order. If you know this, maximum cadence का clear हो जाएगा. Suppose Na plus and H plus is there. Which is more reactive? More reactive means losing electron. Less reactive is taking electron. Okay. So sodium and hydrogen, hydrogen will take electron. If hydrogen and copper is there, copper will take the electron. And zinc and iron is there, iron will take the electron, zinc will lose the electron. Zinc will lose the electron, iron will take the electron. Okay, this is the reactivity series. Then easily you can uh, identify which will undergoing deposit. Less reactive will deposit first. Right? Is it clear about cations? Next, about anions. About anions, you remember OH minus and Cl minus is there. The OH minus is more stable. OH minus is more stable. That's why it is not undergoing oxidation. So OH minus when it will get oxidation whenever sulfates, phosphates, nitrates. When these three are there, these are more stable than OH minus. Stability I am writing. These are more stable means obviously what will happen? OH minus will get oxidation when these anions are present. When these anions are present, OH minus will get oxidation. OH minus से less stable कौन है? Generally X minus I am writing. X minus. What is that X minus? Halogens. In that halogen, if you want to take chlorine, bromine, iodine, chlorine is more stable, Cl minus, then bromine minus, then iodine minus. According to electron negativity, you can give the order. Right. So I will take one example. You have to tell which gases or which metal is depositing at cathode and anode. Okay. So now I am taking here calcium sulfate, aqueous calcium sulfate I am taking. What are the cations here? Calcium plus 2, sulfate 2 minus, H plus, OH minus. Right. Now you tell me at cathode. Is it clear question? Now I am asking the question. At cathode, what it will liberate? At cathode. At cathode. कैथोड में क्या होता है? रिडक्शन रिएक्शन मतलब इलेक्ट्रॉन टेकिंग. Who will take electron? Ca plus 2 and H plus. Which will take the electron? Decide. Tell me. At cathode, what is liberating? At cathode, what is liberating? Yes, Yes, I given information here. Hydrogen. Yes, Pooja, very good. At cathode may cation goes to cathode. Which cations are there here? Ca plus 2 and H plus. Which will take the electron? See, Ca and H. So H plus will take the electron and forming H2. Right. At cathode. What about at anode? At anode, anions are there. Sulfate 2 minus and OH minus. Yes, what it will liberate? At anode getting oxidation. At anode getting oxidation. What it will liberate? H2 and water. See, generally whenever gas we are H2O, H2O the already H2O, so much H2O is there. No need to write H2O beta. Okay, oxygen. Okay, oxygen. Liberating generally oxygen gas वो तो ऊपर आता है ना. Water is forming here only. So much water is there. One more water droplet is there extra. Okay. See, that answer is not wrong, but O2 is enough. Okay. Next. So understood now. Is it clear? So if you see in the textbook also it given, in the material also given. Is it visible? I will send later one pic. So these many are there. If you take magnesium chloride, NaS, copper chloride, copper sulfate, silver nitrate, these many are there. NaOH, okay, sodium hydride, RCONA, okay, potassium sulfate, similar answer, potassium sulfate also. Okay, last one example I will take AgNO3. I will take AgNO3. AgNO3. Last example. AgNO3. Ag plus NO3 minus H plus OH minus. Now tell me at anode and at cathode. Anode and at cathode. Write that. AgNO3. At anode, at cathode, what are forming? Anode, anion. OH minus, NO3 minus. Cation, H plus and Ag plus. Yes. What is forming here? Anode at cathode. At silver at cathode. Okay. Silver at cathode. At anode, only Purva and Prathamesh, Pooja, 3 students replied. What about remaining out of 22? Silver at cathode, okay. What about at anode? Anode में oxidation reaction. सार्थक, oxygen. Yes, oxygen. क्योंकि NO3 minus is already more stable. 100% OH minus will get oxidation, producing here oxygen gas, here hydrogen gas. Okay. So now everyone you understood, I think. Sorry, it is not Ag, right. Silver. Less reactive, always less reactive one gets deposit. Okay? Right. Now, next question, next topic continues here. What is liberating? अभी तक discussion हुआ था. Now, how much quantity it will liberate? How much quantity it will liberate? The topic we are going to discuss now. How much? Okay. So this explanation given by Faraday's. Faraday's laws. Faraday's law of electrolysis. Faraday's law of electrolysis. Okay. What is, he is given two statements. First law. First law is, if you send or if you pass more electricity, more amount of substances will get deposit or evolve. Gases है तो evolve बोलते, solid है तो deposition. The substance deposition is directly proportional to sending electricity. How much electricity you are sending, or how much charge you are sending. Electricity is nothing but the charge. That is the first. W is directly proportional to Q. What is W? Electrolyte deposit. Electrolyte deposited. Deposited. Q is the charge. Charge which we send. Charge, or we can say current. Power, electricity. Current or electricity. How much charge we send? That is directly proportional to the how much deposited. This first point is clear to everyone. Okay, next here we had to know that what is charge and how to calculate the charge. How to calculate the charge. The next formula physics में भी आता है. This Q equal Q charge equal current means I into T. IT. I is current here in ampere. T is the time in second. I in ampere, T time in seconds. So units क्या होगा? Ampere second. Ampere second. Current in amperes, time in seconds. Okay. Current, time. So this formula I can write it now. W equal, in place of Q I can, it's not W equal, W is directly proportional to, in place of Q I can write IT. Then W equal some constant Z IT. What is Z here? Z is some constant. What is that constant? Electrochemical equivalent. Electrochemical equivalent. So how to calculate this Z? Say if I equal to 1 ampere, T equal to 1 second. 1 ampere 1 second means what? Nothing but the Q is 1 coulomb. 1 coulomb. See, charge Q का unit होता है coulomb. Coulombs. Electron charge also in the coulomb, na? Okay. Coulombs. I equal to ampere, 1 ampere, T equal to 1 second. If 1 ampere current passing 1 second, that means the charge is 1 coulomb. So Q equal to 1 coulomb. Just if you put these values here, the W equal to Z. W equal to Z. W equal to Z. Therefore, we can give one statement. Whenever 1 coulomb current is passing through the solution, 1 coulomb solution is, sorry, 1 coulomb current is passing through the solution, that time whatever amount of metal or substance is depositing, that is only known as electrochemical equivalent mass. Electrochemical equivalent mass, that is Z. That is Z. Easy method I will tell you how to calculate. In the numerical question they never give the Z value. We have to calculate. It is very simple, like atomic mass. It is like atomic mass. First you tell me the first formula is clear. First of all, Faraday's first law. Faraday's first law. The amount of the substance here, some substance is depositing. The amount of substance deposited, or electrolyzed, means कुछ electrolysis reaction हो गया, either deposited or electrolyzed is directly proportional to the quantity of electricity passed through the solution. Understood clearly? How much depositing or how much electrolyzed matlab the cleavage. Suppose H2O is there, H2O, it will be by electrolysis H2 plus O2 bante. Okay, that is electrolyzed. How much water is electrolyzed means that is depends on how much electricity you send. That is, in case of NaCl, fused NaCl में Na will deposit. How much Na will deposit? That is directly proportional to how much electricity you send. First point clear. Then formula W equal to W directly proportional to Q. Q is in coulombs. Q equal to IT. Why IT? Charge. Charge equal to current into time. Then W equal to ZIT. What is Z? Electrochemical equivalent mass. I am writing here electrochemical equivalent mass. Electrochemical equivalent mass. What is this electrochemical equivalent mass means? When you send 1 coulomb current, how much metal or substance is depositing? That is only known as electrochemical equivalent mass. Clear? Formula is important. You can take one more screenshot. This final answer, this W equal to ZIT, that is important. Okay, next. Tell me 1 farad means what? 1 farad. What is 1 farad? 1 farad. 1 farad equal to dash coulombs. Anyone? 1 farad equal to dash coulombs. 96,487 is the correct answer. For our convenience, we will take 96,500. Okay, 96,500 we will take. Actual value is 96,487. Good. Given that, others. Very good. Okay, approximately 500. Calculation easy hota hai, that's one. Coulombs. How this value we got it? In the chemistry, what is the these many coulombs means how many electrons charge it is equal to 96,500 coulomb equal how many electrons charge? How many electrons charge? Electron also has some charge, right? How many electrons charge it is? One electron charge how much? 1.6 into 10 power minus 19 coulombs. ये भी coulomb है, ये भी coulomb है. Now tell me how many electrons together this much? Yes, one electron charge is 1.6 into 10 power minus 19. That's right. I am asking how many electrons together contribute this much energy, this much charge. How many electrons? 6.0. Little correction is there. 6.022 into 10 power 23 electrons charge is equal to 96,500, that equal to 1 farad. So now onwards, whenever you say 1 farad current means nothing but 1 mole electron. We are in the chemistry, not in the physics. So chemistry may, whenever in the numerical 1 farad, 2 farad is there, means 2 farad means 2 moles electrons. 1 farad means 1 mole electrons. Okay. 10 power 23, it is Avogadro number, nothing but 1 mole. 1 mole electrons. 1 mole electrons charge equal to 1 farad. It is clear to everyone? Okay. Right. Now, I am coming to the question here. Battery is there. So, I am using here 2 farad current. 2 farad current, मतलब इधर भी 2 farad ही होगा. 2 farad current. I am taking initially fused NaCl. Fused NaCl. Fused NaCl. What is the meaning? Fused NaCl. मतलब molten मतलब semi liquid type NaCl I am taking. Then electrolysis process is going on. I use 2 farad current. Now you tell me at cathode cation will get deposit. What is that? Sodium. At cathode dash grams of sodium will deposit. Then at anode dash liters of chlorine will liberate STP condition. Chlorine volume we are asking means randomly we cannot ask. So that is STP condition. Now give me first question answer. Second question answer I will explain. Little tricky. First one easily you can give. At cathode cation will goes to cathode, getting reduction, depositing. Right. I am asking you how many grams of sodium will deposit? At cathode, how many grams of sodium will deposit? I given you 2 farad current. Concept clear means answer फटाफट आना चाहिए. For this calculation no need calculator, direct answer. 46 is the correct answer. Very good. Purva, Siddharth, 46 is the correct. If I use 1 farad, 1 mole electrons, say Na plus required 1 electron and forming Na. If I use 10 electrons, 10 sodium will deposit. If I use 1 mole electron, 1 mole sodium will get deposit. If I use 2 mole electrons, 2 mole sodium will get deposit. I am using 2 farad means what? 2 farad means 2 mole electrons. When I use 2 mole electron, how much it will form? 2 moles it will form. 2 moles. 1 mole is sodium 23, 2 mole 46. So answer is 46. Still, if anyone not understood, you can ask. 46 is the correct answer. Everyone you understood? Send the message at least yes or no. Fast. Right. Next question is chlorine. Chlorine. Can you try? First you calculate how many moles. Then gas. 44.8. Once we will see is it 44.8 or not. See here 2 farad means 2 moles of electrons are exchanging. 2 moles of electrons. Because Cl minus when it is lose electron I am taking 2 Cl minus taking Cl2 and 2 electrons. Okay, 2 electron. If I take 2 moles electron left means how many moles of chlorine is forming? 1 mole of chlorine is forming. 1 mole of chlorine is forming. So how much? 1 mole equal to 22.4 liter at STP. 22.4 liter at STP. Okay, Purva, understood now? See, what you did, one chlorine is forming, one chlorine, so 2 chlorines are there means 22 point. No, it's a diatomic molecule. That's why I given the question. Okay, so simple question. See, concept we understood. Later also some chances are there to do the mistakes. That's why I'm giving all possibilities, whatever where the student will do the mistake. Maximum those questions I will explain here. Okay, right. So it is clear now. 22.4 liter at STP. So this is the important here. Right. Now ये क्वेश्चन का थोड़ा आगे मैं एक्सटेंड करता हूं. 1 ampere current नहीं तो 1 नहीं 2 ampere current 2 ampere current send 2 minutes 2 ampere current send 2 minutes through aqueous NaCl solution. Aqueous NaCl solution. Aqueous NaCl solution. Right? Now, at anode, at anode, at anode, how much gas? How much gas is liberating? How much gas liberating? And which gas it is? And which gas it is? And which gas it is? Quantity as well as which gas? Aqueous NaCl. Aqueous NaCl में Na plus Cl minus H plus OH minus. Okay. Na plus Cl minus H plus OH minus. What is asking here? At anode asking. Anode में oxidation. Which will get oxidation? Cl minus and OH minus. Cl minus will get oxidation. So Cl2 is forming. The first one answer is Cl2. Clear. Next thing is how much quantity? Then see the quantity W equal Z I T. Z value we don't know. Yes, Z value we don't know, but we can calculate what is Z. 1 coulomb. When 1 coulomb is passing, how much the gas or metal is depositing or liberating, right? So 96,500 coulombs, 96,500 coulombs charge whenever exchange, how much chlorine will get deposit or liberate. देखो Cl minus is forming half Cl2 and take losing one electron. Cl minus half Cl. Okay, 96,500 means what? 1 mole electron. When 1 mole of electron is exchanged, how much chlorine will get deposited? 35.5 grams. 35.5 grams. Is it clear? When 1 mole of electron is exchanging, that means 96,500 coulombs, 35.5 gram chlorine is liberating, or I can say half mole also. This equal to half mole. This equal to 11.2 liter. Is it clear? All three is correct. 35.5 or half mole or 11.2 liter ADSTP. Okay. Then 1 coulomb में क्या होगा? 1 coulomb cross multiplication you have to do. Cross multiplication. This is only Z. This is only Z. Then Z equal 35.5 upon 96,500. This is the Z value. Z value, that's why they don't give in the numerical question. Z value we have to do. Okay. Some other example also I will give you here. Suppose sodium is there. Sodium का क्या होगा? Sodium, for sodium the Z value is 23 gram upon 96,500 coulomb. Okay, if you use 96,500 coulomb, 23 gram will deposit. For 1 coulomb, how much? Okay, like this. Suppose magnesium is there. For magnesium क्या होगा? 96,500 coulomb में here it will be deposit only 12 grams. क्योंकि each magnesium required 2 electrons. Okay, we will discuss in the next one. Second law is it will tell that. Okay, so now this value put it here, 35.5 upon 96,500 into I equal to 2. Then T in seconds, T equal 2 minutes. 2 minutes means 60, I equal to again 60 into 60. Yes, sorry, 60 seconds, 60 into 2. Right? 1 minute means 60 seconds, 2 minutes means 2 into 60 seconds. Now if you do this calculation, you will get weight, mass. Okay? Then converting into moles, then liters. Is it clear? This numerical you have to do. This equal, approximate I will do. Approximately, so 0, 0 get cancelled, 12, 24, 35.5 into 24 by 9650. Then if I keep the decimal here I can take, then 24 threes are 72 means 7.2 upon 96. So here if I take 0.9 and 10 square I can write it. So 10 square will goes up, 10 power minus 2. 7.2 upon 0.9. 0.9 means 1 है तो 7.2 as it is. 0.9 is there means 7.2 से आगे approximately 8 into 10 power minus 2. That means 0.08. It's an approximate answer. Okay. So like that you can do. Sorry, it is in the gram only. Next, what we have to do in the liter means convert into moles into 22.4. If I do here, how many grams that is? 0.08 grams. 0.08 gram upon 35 atomic 71, क्योंकि Cl2 का मास क्या होता है? Cl2 71 35.5 into 2 into 22.4. This will be the your answer. Very less. Okay, this is the answer. Understood how to calculate? See here, important thing is only Z. Z how to calculate, I explained you. Understood everyone? Right. Next, Faraday's second law. Faraday's second law. Faraday's second law. So here I am taking NaCl. Here I am taking same type of experiment here. I am taking here. Yes, madam. Yes.
The right in center, left side is not visible.
Okay. Okay. Right. Similar, same experiment I am taking. Okay, here it is aluminum chloride. It is NaCl. It is NaCl. It is aluminum chloride. Okay, positive, negative. Right, everything is same. Now I am taking here 1 farad. I am taking 1 farad. I am taking here 1 farad current. Here also same 1 farad current I am taking. Now, how much sodium will get deposit? Sodium. How much sodium will get deposit? How many moles? See, 1 Na plus required 1 electron forming 1 sodium. But in case of aluminum chloride, Al plus 3 electrons forming 1 aluminum. If I use 1 farad current here, 1 farad current means 1 mole electrons. Okay, so how many moles will deposit here? 1 mole deposit. 1 mole deposit. I am using 1 farad current. If I use 1 farad current, 1 mole. Here also I am using 1 farad current. 1 farad current I am using. How many moles of aluminum will get deposit? How many moles of aluminum will get deposit? Aluminum. How many moles? 1 by 3 moles. 1 by 3 moles because 3 electrons required for 1 aluminum. 3 electron required for 1 aluminum. That's why 1 by 3 mole. 1 by 3 mole it will get deposit. So if I write in the mass, what it is? 23 gram. Here it is only 9 grams. 9 grams. 23 gram here, 9 gram here. What is this? 9 gram is equal to equivalent mass of aluminum. Equivalent mass of aluminum equal 9 grams. Equivalent mass, how to calculate? In the normality you learned. Equivalent mass equal 27 by 3, that equal to 9. Why 3? Because aluminum ka valence is 3. Okay, so if you use the final conclusion is, if you send same amount of electricity through the different solutions, same amount of electricity through different solution, the metals depositing amount, the metals depositing amount is directly proportional to their equivalent mass ratio. Equivalent mass ratio. Equivalent mass ratio. Example here. Suppose if I use magnesium chloride. If I use magnesium chloride, I am using only 1 farad. How much magnesium will get deposit? Magnesium depositing mass. How much magnesium will get deposit in the grams? In gram. 1 by 2 mole. Yes, 1 by 2 mole. That means 24 by 2. 1 by 2 mole. 24 by 2. That means 12 grams. 12 gram. The 12 gram also is equal to magnesium equivalent mass. Magnesium equivalent mass. Okay. The second law is telling that whenever same amount of or same quantity of electricity here and here, same quantity of electricity passed through the solutions, passed through the different solutions, the deposited mass, here also something deposited, here also something deposited. The deposited mass is directly proportional to their equivalent mass ratio. Equivalent mass ratio. Therefore, I can write one formula here. W1 by W2 equal E1 by E2. What is this equivalent mass ratio? Equivalent mass ratio. Equivalent mass ratio. Here continue कर सकते हैं. ठीक है इतना ही. So now this is the final formula. W1 by W2 equal to E1 by E2. So how to solve the question? I will give one example here. Question number 2. Same amount of charge passed through sodium, magnesium, aluminum chloride solutions. Chloride solutions which are connected in the series. Now, aluminum deposited 27 gram. Aluminum deposited 27 gram. Then calculate sodium and magnesium metals mass at their respective electrodes. Question समझ गए पहले. This one cell is there, here बाजू में one more cell is there, and side one more cell is there. Roughly I am writing here. Here one more cell is there, here also one more cell is there. Here magnesium, here aluminum. These are connected. Series connection is there. The total is current. The total current is only how much? Not given. Same amount. सोडियम का कितना मिल रहा है, मैग्नीशियम का भी वही अमाउंट है, एल्यूमिनियम का आल्सो सेम अमाउंट ऑफ इलेक्ट्रिसिटी पासिंग all these three solutions, same amount. Here information given, aluminum deposited 27 gram. Now here you have to calculate magnesium and sodium, how much deposited you have to calculate. Now you tell me, question you understood now or not? What is asking question? At least you understood question, right? After that, substitute, you use this formula. Okay. Now I am taking it is the aluminum, it is the magnesium. Okay. Tell me aluminum how much? Okay. Here one is aluminum I am taking. One is aluminum. Two is magnesium I am taking. Two is magnesium. Right. Aluminum how much mass deposited? 27 gram. 27 gram deposited upon magnesium. तो वही कैलकुलेट करना है W equal equivalent mass of aluminum. Equivalent mass of aluminum. How much? 9 gram. Equivalent mass of magnesium 12 gram. Equivalent mass of aluminum 9 gram. Equivalent mass of magnesium 12 gram. In 9 and 12, is it clear? Magnesium 36, sodium 69. Okay. Okay, Prathamesh, you are good, but everyone need to understand. Okay, what I'm doing here, I'm taking aluminum is 1 and magnesium is 2. So W1 by W2 equal to E1 by E2 formula. Now W aluminum upon W magnesium. W magnesium we don't know, that's only we are going to calculate. But equivalent mass already we know. Equivalent mass. Aluminum equivalent mass 9, magnesium equivalent mass 12. Then do the calculation. 3, 3 is 3, 4 is then W magnesium equal, if you take it there, 27, 3 1 3 9 9 into 4, 36. Yes, 36. Magnesium is 36 grams. Clear? Similarly, you can apply here magnesium. In place of magnesium, you can take sodium. In place of magnesium, you can take sodium. You will get 69 gram. 69 gram. Everyone, you understood? Is it clear? How you calculated equivalent mass? Others. बेटा equivalent mass normality कुछ idea है? Normality equivalent mass equal to molecular mass upon valency. Molecular mass upon valency. Sodium का valency is 1. That's why upon 1. Magnesium का valency 2. That's why upon 2. Aluminum valency 3. That's why upon 3. Okay, if you learn normality, in the normality we will use equivalent mass only. Once you revise that normality, if you are not understanding, then you can ask in the next class. Okay, right. So Faraday's first law over, second law over. So everyone, as soon as you take these materials, okay, solve the questions. Next, abhi almost physics topics. Ohm's law. What is Ohm's law? Ohm's law. Sorry. V equals IR. Voltage equal I, the current, R is the resistance. Yes, V equal IR. The physics may you learn that. Now here R is the resistance. R is the resistance. R is directly proportional to resistance is R. Now R is directly proportional to L. Oh, wire रहता है ना, wire, iron wire, whatever wire is there. If the distance is increasing, the resistance also increase. Okay, R is inversely proportional to A. If the area is increasing, so electron can move, many electrons can move, so the current is passing easily, so resistance is decreasing. So R directly proportional to L, R inversely proportional to A. I can write this one, R proportional to L by A. Here R equal K into L by, not K here, rho. Rho L by A. Equation number 1, 2, 3, 4. What is rho here? Rho is some constant. Rho is depends on the substance. Suppose iron wire is there. Iron wire ka rho is different. Copper wire ka rho different. Aluminum wire ka rho is different. It is specific resistance. It is known as specific resistance. स्पेसिफिक रेसिस्टेंस. एक एल्यूमिनियम है तो एल्यूमिनियम के लिए वो फिक्स होता है, आयरन है तो आयरन के लिए फिक्स. स्पेसिफिक रेसिस्टेंस. R is complete resistance. L length, A is area. ये फार्मूला everyone you know this formula. It came in the physics. Everyone you know this. Yes. So in the chemistry, we don't take iron rods, iron wire. Here we are taking electrodes. We are taking electrodes. Right? So this electrode distance, here this distance is L. If these electrodes are keeping 10, 1 meter distance, suppose 1 meter distance, then electricity cannot pass. If you keep it very small distance, then obviously electricity can pass. So that means when the distance is increasing, resistance is increasing. Then the area, it has some area. It is just plate. It is a plate. It is not rod. Plate type is there. Some area is there. If big area is there, so electron can move from here also, here also, here also, here also. So resistance is decreasing. So that is the area A. So R directly proportional to L by A. R is directly proportional to L by A. Here R equal rho L by A. Okay, physics and chemistry में इतना difference है. In the physics we will take iron wire or copper wire. Here we are taking electrodes. Distance between electrode is L. Area between the two electrode is A. Okay, formula is same. Is it clear? Yes. Now here these electrodes are fixed. Fixedly it is with screw. They will tight. In the beaker type is there. In the beaker, two electrodes are fixed. That means always in between the two electrodes, the distance is same. If you take one equipment, one apparatus, if you take one apparator, in that the two electrodes the beach में distance is same, the area also same. So finally L by A is constant. L by A is constant for one electrolytic cell, for a cell, for electrolytic cell, electrolytic cell. Generally, we will take the fixed one only. We movable, it's not. Okay, L by A is constant for a electrolytic cell. So that's why even on the cell they will mention that what is L by A value. Every time, no need to measure that. L by A value they will write it on the cell only. So this why that's why it is known as cell constant. It is known as, therefore it is known as cell constant. It is known as cell constant. The symbol in the different books, different we are taking here cell constant G. Sometimes G star लेते हैं. So I will take G star. G मतलब again Gibbs energy कहाँ से आया? You may think. So G star. Cell constant G star equal L by A. G star equal L by A. Now formula here R equal to क्या होगा? R equal to rho G star. Rho G star. See here small formulas will come around 10 formulas. Okay, because this is also one formula. This is also one formula. This is also one. This is also one. Of course, one is depend on others. Okay, cell constant. In the name only is there. Cell may constant रहता है. The distance and area. L by A, that is cell constant. L by A की जगह पे if you put the G star, rho equal to R equal to rho G star होगी, right? Clear? Next, conductivity. What is conductivity? Conductivity is inversely proportional to conductivity to C, inversely proportional to 1 by R. If resistance is more, conductivity is less. If conductivity is more, resistance is less. So this is one more equation. I can write here some number 5. Okay. Then R equal to same value I am keeping here. Sorry, it's not directly proportional. See the C equal to 1 by R. C equal to 1 by R. C equal to 1 by this rho into L upon A. Then C equal, this A will go up. Here 1 by rho is there. I will write here 1 by rho into A by L. This C equal small k into A by L. Here one more formula. What is K here? K equal to 1 by rho. What is rho? Rho is specific resistance is rho. Here K is specific conductivity. Specific conductivity. What is the C? Conductivity. C and R is a big. C is the conductivity, R is the resistance. Rho is specific resistance. K is specific conductivity. Specific conductivity. So C equal K into A by L. I can write here C equal K A by L. L by A is G star. मतलब 1 upon G star I can write it. K by G star. So same formula I can write here. Specific constant, specific conductivity K equal C G star. G star into C. See, if I write like this, many formulas will come, but formulas though only few are there. Okay, understood everyone? This much clear. Tomorrow we will go ahead. So after this, molar conductivity is there. Molar conductivity, molar equivalent conductivity. उसके बाद Kohlrausch law. Okay. So formulas, everyone you note down, take screenshot. I will send the material. Already I sent you. In that also formulas are there. Everyone write the notes. No one sending recently. From last 1 week, no one sending. Already I sent you PDF. You note down. Okay. Topic आगे पीछे होगा कोई बात नहीं है. You can write as the PDF or you can follow my topics. Which topic I covered? Same topic you write it. Understood? So tomorrow Sunday. So by Monday, everyone, you need to upload electrochemistry notes. Okay, electrolytic and electrochemical series, both. Yes, right. Okay, bye. Be in the online only. Next period, sir will come.
అది వచ్చి డౌన్లోడ్ తర్వాత చేద్దాం నా సెషన్ కూడా అయిపోయాక